Picture this. You're standing in your backyard, digging a hole for a new tree. 3 feet down, you hit something hard. It's not a rock. It's smooth, geometric, clearly manufactured. You dust it off and realize you're holding an object that shouldn't exist. Not here, not at this depth, and definitely not made from materials that seem to shimmer with their own inner light. You check the soil layers around it. According to everything you know about geology, this thing has been buried for tens of thousands of years, maybe more. Now, what if I told you that scattered across our planet, in the deepest layers of sediment, beneath ocean floors that haven't seen sunlight since before the pyramids were even dreamed of, there might be traces of something extraordinary, evidence of minds that thought, hands that built, and civilizations that thrived when our ancestors were supposedly just learning to make fire? What if Earth had an advanced society 100,000 years ago? Welcome back to Before Law, where we dig deeper than history books dare to go. I'm your host, and today we're going to explore one of the most mind-bending possibilities our planet has ever hidden. If you're new here, this is where we ask the questions that make archaeologists uncomfortable and challenge everything you thought you knew about human history. And if you're enjoying this journey into the impossible, hit that subscribe button because we're just getting started. Here's something that's going to mess with your head right from the start. Everything you learned in school about human civilization follows a neat little timeline. Hunter-gatherers discovered agriculture around 12,000 years ago. The first cities appeared maybe 6,000 years after that. Writing systems emerged, kingdoms rose, empires fell, and eventually we got to where we are today with smartphones and space stations. It's a tidy story. Problem is, tidy stories are usually missing something important. See that entire timeline of human achievement? It covers maybe the last 10,000 years if we're being generous. But modern humans, people with brains identical to yours and mine, have been walking this planet for at least 300,000 years. 300,000. Let that sink in for a moment. We've been around 30 times longer than our entire recorded history suggests we've been doing anything interesting. For 95% of our existence as a species, we supposedly just wandered around in small groups, occasionally painting on cave walls. Does that seem right to you? Now, I'm not saying our ancestors were secretly building starships or anything like that. But here's where things get genuinely weird. We assume they were primitive because that's what the evidence shows. Except, and this is crucial, the absence of evidence isn't the same as evidence of absence, especially when you're talking about timescales that make recorded history look like yesterday's newspaper. Think about your house for a second. How long would it last if everyone just disappeared tomorrow? The roof starts leaking within a few years. Plants grow through the foundation. Weather beats down the walls. In a century, it's rubble. In 1,000 years, it's a weird-shaped hill that future archaeologists might mistake for a natural formation. Now multiply that by 100. Over 100,000 years, the Earth doesn't just hide evidence, it devours it. Wind and rain grind mountains into sand. Tectonic plates slide around like pieces of a cosmic jigsaw puzzle, dragging entire continents to new positions. Ice ages come and go, scraping the surface clean with glaciers the size of countries. Ocean levels rise and fall by hundreds of feet, drowning vast stretches of land that might have once been home to millions of people. In geological terms, 100,000 years is enough time to erase almost everything. Not some things. Almost everything. The fact that we haven't found cities or machines from that era might not mean they never existed. It might just mean the planet has been very, very thorough about cleaning up. But here's where it gets interesting. While mainstream archaeology focuses on the last few thousand years, there are scientists who've started asking a different question. Not whether ancient civilizations existed, but how we'd even know if they did. In 2018, 2 researchers published something called the Silurian hypothesis. Don't let the science fiction name fool you. This was serious academic work. They asked a simple question. If an industrial civilization had existed on Earth millions of years before humans, what traces would it leave behind? Their answer was unsettling. Very few that we'd easily recognize. Physical artifacts, gone. Buildings, dust. Even massive infrastructure projects would be nearly invisible after that much time. But here's what might survive: chemical signatures, weird spikes in carbon levels, unusual isotope ratios in ancient rock layers, traces of synthetic materials that don't occur naturally. The fingerprint of intelligence wouldn't be found in museums. It would be hidden in the chemistry of the planet itself. Now, these scientists weren't claiming that such a civilization actually existed. They were doing something more important. They were showing us that our methods for detecting ancient intelligence might be fundamentally flawed. We've been looking for the wrong things in the wrong places. And that raises a terrifying possibility. What if we've already found the evidence and just didn't recognize it? Let me paint you a picture of what Earth looked like 100,000 years ago. This isn't speculation. This is geological fact. The planet was in the grip of an ice age, but that doesn't mean everywhere was frozen solid. Vast ice sheets covered much of North America and Northern Europe, but the tropics were still warm. More importantly, sea levels were over 300 feet lower than they are today. 300 feet. That means enormous stretches of what is now ocean floor were dry land. Rich, fertile coastal plains where rivers flowed and life flourished. The area between England and France, dry land. The connection between Alaska and Siberia, a vast bridge of grassland and forest. Huge areas of what is now the continental shelf were above water, providing millions of square miles of prime real estate for any intelligent species that wanted to build something permanent. And here's the kicker. When the Ice Age ended and those glaciers melted, all of that land disappeared beneath the waves. If someone had built cities, ports, or monuments in those areas, they're now sitting under hundreds of feet of ocean, covered by thousands of years of sediment. We've barely explored 1% of the ocean floor in any detail. The rest is as mysterious to us as the surface of Mars. But let's get back to the people who were definitely there. Anatomically, modern humans had been around for at least 200,000 years by this point. They weren't shambling cave dwellers, barely smart enough to avoid getting eaten by saber-toothed cats. These people had the same brain capacity we have today. They were making sophisticated tools, creating art, and almost certainly had complex languages. We know this because of the few traces that did survive. Cave paintings that show an understanding of perspective and artistic technique. Carved figurines with details so fine they required specialized tools to create. Evidence of long-distance trade networks that moved materials across continents. These weren't the products of primitive minds struggling to survive. These were the works of people who had time, skill, and cultural sophistication. So here's the question that should keep you up at night. If people with our intelligence had been around for hundreds of thousands of years, living in a world with vast unexplored continents and untapped resources, what might they have achieved that we'll never know about? The standard answer is nothing much, because we haven't found evidence of anything impressive. But that assumes evidence from 100,000 years ago would still be lying around waiting for us to discover it. And as we've already established, that assumption might be completely wrong. Consider this. The oldest surviving stone structures we know of are maybe 12,000 years old, and even those were buried and forgotten until recently. We have no permanent architecture from 50,000 years ago, let alone 100,000. But the absence of stone buildings doesn't mean the absence of civilization. What if they built with different materials? What if they used advanced organic compounds that were stronger than steel, but designed to biodegrade completely over time? What if they were smart enough to live sustainably, creating technology that worked with natural systems instead of against them? Such a civilization could have existed for thousands of years while leaving almost no trace we'd recognize today. Their cities might have been grown rather than built. their tools crafted from materials that returned to the earth when their purpose was complete. We're so used to equating advancement with permanence, with leaving a mark that lasts forever. But maybe that's just our bias. Maybe true advancement means learning to thrive without scarring the planet. If that's the case, then the most advanced civilization in Earth's history might be invisible to us precisely because it was so successful. This isn't just idle speculation. There are anomalies in the archaeological record that don't quite fit the standard timeline. Objects that seem too sophisticated for their supposed age. Artifacts found in geological layers where they shouldn't exist. Most of these have conventional explanations once they're studied in detail, but a few continue to raise questions. More intriguingly, there are chemical signatures in ice cores and sediment samples that show unusual spikes in certain elements during periods when, according to our current understanding, nothing interesting should have been happening. Sudden increases in carbon levels, weird concentrations of rare metals, isotope ratios that don't match any known natural process. Individually, each of these anomalies can be explained away. Volcanic activity, asteroid impacts, natural climate fluctuations. But taken together, they form a pattern that's harder to dismiss. A pattern that looks suspiciously like the kind of chemical fingerprint an advanced civilization might leave behind. And then there are the stories. Every culture on Earth has legends of a time before time, when the world was different and great civilizations rose and fell. The Greeks had Atlantis. The Indians speak of advanced cities mentioned in texts thousands of years old. Aboriginal Australians have Dreamtime stories of lands that were swallowed by rising seas. Norse mythology describes worlds that existed before this one. Usually, we dismiss these as pure mythology. But what if they're not? What if they're cultural memories, distorted by thousands of years of retelling, but based on something real? Oral traditions can preserve information for remarkably long periods. Some Aboriginal stories have been traced back to actual geological events that happened over 7,000 years ago. If memories can survive that long, what might our deepest myths be trying to tell us? The more you dig into this possibility, the more unsettling it becomes. Not because it's impossible, but because it's entirely plausible. We live on a planet that's 4.5 billion years old. Complex life has existed for hundreds of millions of years. Intelligence, as far as we know, has evolved at least once. Why assume it only happened recently? The universe doesn't care about our timelines or our assumptions about progress. It doesn't guarantee that intelligence will leave behind monuments or museums for future species to discover. It just lets things happen, and then it lets time erase most of the evidence. So we're left with a mystery wrapped in geological time and buried under layers of our own certainty. Did an advanced civilization exist on Earth 100,000 years ago? We may never know for certain, but the fact that we can't rule it out should change how we think about our place in history. We might not be the first. We might not even be the second or third. We might be the latest in a long line of intelligent species that rose to prominence on this planet, achieved things we can barely imagine, and then faded into the geological record, leaving behind only whispers and anomalies for the next civilization to puzzle over. And if that's true, it raises one final crucial question. What will future archaeologists make of us? The thought should terrify you. Right now, as you're listening to this, there are layers of sediment forming on ocean floors around the world. In 100,000 years, some future species might drill down through those layers and find traces of our plastic, our concrete, our radioactive isotopes from nuclear testing. They might piece together that something intelligent lived here once, but would they understand what we were really like? Would they know we wrote poetry, that we fell in love, that we spent our evenings watching sunsets and wondering about the meaning of existence? Or would they just see the chemical residue of an industrial civilization and move on, filing us away as another curious blip in the planet's long history? This brings us to something that's been bothering researchers for decades. The deeper we dig into Earth's past, the more we realize how much we don't know. And I'm not talking about minor gaps in the fossil record. I'm talking about entire epochs, where our understanding is based on educated guesswork and a handful of scattered clues. Take the period between 50,000 and 200,000 years ago. We call it the Middle Paleolithic, which is just a fancy way of saying the time when we assume nothing particularly interesting happened. During this period, modern humans were spreading across the planet, developing the cognitive abilities that would eventually lead to art, agriculture, and civilization. But our knowledge of what they actually did during those 150,000 years is embarrassingly thin. We have some stone tools, a few cave paintings, evidence of fire use and basic hunting techniques. From this meager collection of artifacts, we've constructed an entire narrative about human development. But here's what's troubling. The gap between the sophistication of these early humans and the complexity of the civilizations that suddenly appeared around 10,000 years ago is enormous. It's like finding a child's crayon drawing, and then, in what appears to be the very next room, discovering the Sistine Chapel. The jump is so dramatic that it almost suggests there were intermediate steps we're missing. Stages of development that existed but left no trace we've been able to identify. Now let me introduce you to a concept that's going to change how you think about archaeological evidence. It's called preservation bias, and it's the reason we might be fundamentally wrong about the past. Imagine you're an alien archaeologist visiting Earth 1 million years from now. You want to understand early 21st century human civilization, so you start digging. What would you find? Well, it depends entirely on where you dig and what materials happen to survive. If you excavated in a desert, you might find fragments of glass and metal that lasted because of the dry conditions. You might conclude that humans were a civilization obsessed with transparent materials and metalworking. If you dug in a former forest, you'd find almost nothing, because organic materials decompose quickly in humid environments. You might decide that particular region was uninhabited. If you were really unlucky and only excavated in areas that had been ocean floor during our time, you'd find no trace of human civilization at all. You might conclude that intelligent life never evolved on Earth. This is the problem we face when trying to understand the deep past. We don't find a representative sample of what existed. We find only the tiny fraction that happened to survive in conditions that prevented decay, in locations that weren't subsequently destroyed by geological processes, and in places where we've thought to look. The vast majority of human activity throughout history took place in areas that are now underwater, eroded away, or buried under miles of sediment. We're not just missing pieces of the puzzle. We might be missing entire puzzles. But let's get specific about what survival means over these timescales. Metal objects, which we think of as durable, actually have a very limited lifespan when exposed to the elements. Iron rusts completely away within a few centuries in most climates. Copper corrodes into unrecognizable green powder. Even aluminum, which we consider highly resistant to decay, will eventually oxidize and crumble. Stone lasts longer, but not as long as you might think. The Easter Island statues are only about 1,000 years old, and they're already showing significant erosion. The Great Pyramid of Giza, built from some of the most durable stone on Earth and maintained by countless generations, has lost its outer casing and much of its internal structure in just 4,500 years. Now imagine trying to preserve something for 25 times longer than the pyramids have existed. The mathematics of decay are brutal. Every year that passes reduces the chances of survival. Every flood, earthquake, and storm chips away at what remains. Over 100,000 years, even the most massive monuments would be reduced to scattered fragments that might easily be mistaken for natural rock formations. This is why the absence of ancient cities doesn't necessarily mean they never existed. It might just mean they were built from materials that couldn't withstand deep time, or in locations that have since been claimed by the sea or using techniques that we haven't learned to recognize as artificial. Consider organic architecture, for instance. What if an ancient civilization had mastered biotechnology to a degree we're only beginning to imagine? What if they grew their cities rather than building them, using engineered organisms that created structures as complex as any modern skyscraper, but designed to return to the Earth when their purpose was complete? Such a civilization could have existed for millennia, achieving levels of sophistication that would make our current technology look primitive, while leaving behind nothing more than unusually fertile soil and maybe some anomalous chemical traces in the geological record. It sounds like science fiction, but consider what we're already doing with synthetic biology. We're engineering bacteria to produce medicines, creating organisms that can break down plastic waste, developing living materials that can self-repair and adapt to changing conditions. Now imagine what might be possible with 100,000 years of additional development. Or think about energy systems. Our civilization is built on burning things, splitting atoms, and harnessing the power of wind and water through massive mechanical systems. But what if there were more elegant solutions? What if an ancient civilization had learned to tap into the Earth's magnetic field, or to convert atmospheric pressure differentials into usable power, or to store energy in crystalline matrices that we'd mistake for natural mineral formations? Such technologies might leave no recognizable infrastructure, no power plants, no transmission lines, no fuel depots, just subtle modifications to natural systems that continued to function long after their creators were gone, until eventually even those faded back into the planet's normal processes. This isn't wild speculation. We know that biological systems can perform feats that our best technology can't match. A single leaf can convert sunlight into chemical energy with an efficiency that surpasses our best solar panels. The human brain processes information using less power than a light bulb. Bird navigation systems put our GPS satellites to shame. If an ancient civilization had learned to work with these natural capabilities instead of against them, they could have achieved remarkable things while leaving almost no trace for future archaeologists to discover. Their greatest achievement might have been learning to live so lightly on the Earth that their passing was barely noticed. But here's where things get really interesting. What if they didn't completely disappear? What if some traces of their knowledge survived, not in artifacts or ruins, but in the genetic code of life itself? We're just beginning to understand how information can be stored in DNA. Scientists have already succeeded in encoding digital data into bacterial genomes, creating living libraries that can replicate themselves and preserve information for thousands of years. Now imagine a civilization that had perfected this technique, embedding crucial knowledge into the genetic structure of plants and animals that would survive whatever catastrophe befell them. The instructions for rebuilding their technology, their history, their philosophy, could all be hidden in the DNA of species that still exist today. We might be surrounded by an ancient library written in the language of life itself, completely unaware that it exists because we don't know how to read it. This possibility becomes even more intriguing when you consider the sudden leaps in human development that punctuate our archaeological record. The rapid development of agriculture in multiple locations around the same time. The simultaneous invention of writing systems in different parts of the world. The mysterious knowledge of astronomy and mathematics that appeared in ancient civilizations without any obvious developmental pathway. What if these weren't independent innovations? What if they were the result of accessing information that had been preserved from an earlier time, encoded in ways we're only now beginning to understand? I know how this sounds. I know it pushes the boundaries of what we're comfortable believing about our past. But that's exactly why it's worth considering. The most important discoveries in science have always come from questioning assumptions that everyone thought were safely established. And the assumption that human civilization is only a few thousand years old, that we're the first intelligent species to significantly modify our planet, that technological advancement necessarily leaves behind durable physical traces. These assumptions might all be wrong. If they are, then we're not just misunderstanding our past, We're misunderstanding our present and our future as well. Because if intelligence has risen and fallen on this planet before, it could happen again. And if previous civilizations found ways to live sustainably for tens of thousands of years before ultimately disappearing, maybe there are lessons we need to learn from their success and their failure. The evidence, such as it is, remains tantalizingly ambiguous. Chemical anomalies that could be natural or artificial. Genetic patterns that might reflect ancient manipulation or random evolution. Stories and legends that could preserve real memories or pure imagination. But absence of proof is not proof of absence. And in a universe that's had billions of years to experiment with intelligence, the idea that we're the first to get this far seems almost absurdly unlikely. So the question remains open, hanging in the space between what we know and what we can imagine. Did an advanced civilization exist on Earth 100,000 years ago? We may never find definitive proof, but the possibility alone should change how we see ourselves and our place in the vast story of this planet. We might be pioneers, blazing a trail into an unknown future, or we might be following a path that others have walked before us, learning lessons they learned, making mistakes they made, and perhaps, if we're very careful and very wise, avoiding the fate that ultimately claimed them. Either way, we're part of something much larger and more mysterious than we usually allow ourselves to believe. And that mystery is written not just in the rocks beneath our feet, but in the very air we breathe and the genetic code we carry in our cells. The deeper we venture into this possibility, the more we realize that our entire framework for understanding ancient intelligence might be fundamentally flawed. We've been searching for our own reflection in the archaeological record, looking for metal tools, stone monuments, and recognizable technology. But what if intelligence doesn't always express itself the way we expect? Let me tell you about something that happened in the Amazon rainforest that completely changed how archaeologists think about lost civilizations. For decades, scientists assumed the vast jungle was essentially untouched wilderness, sparsely populated by small tribes living simple lives. Then, satellite imagery revealed something extraordinary hidden beneath the canopy. Geometric earthworks, massive patterns carved into the landscape. Roads, plazas, and settlement networks covering areas larger than entire countries. But here's the thing that blew everyone's minds. These weren't made of stone or metal. They were made of earth and wood, materials that should have vanished centuries ago. They only survived because the jungle protected them, and even then, we almost missed them entirely. If the trees hadn't been cleared for modern development, revealing these patterns from above, we might never have known they existed. Now multiply that realization by 100. If sophisticated earthworks from just a few hundred years ago were nearly invisible to us, what might be hidden from civilizations that vanished 100,000 years ago? What if we've been walking over the remnants of ancient cities our entire lives without ever realizing what lies beneath our feet? This brings us to one of the most unsettling aspects of this whole question. The problem isn't just that evidence might be missing, it's that we might not recognize evidence when we see it. Our brains are pattern-matching machines, but they only match patterns we already know. Show someone from the Middle Ages a computer circuit board, and they'd see meaningless scratches on a piece of metal. Show us the technology of a civilization that developed along completely different lines, and we might make the same mistake. Think about how we define technology in the first place. We associate it with mining, smelting, manufacturing, leaving scars on the landscape as we extract and reshape raw materials. But that's just one possible path. What if another species had learned to work with biological systems so sophisticated that their tools literally grew themselves? We're already seeing hints of this in our own development. Scientists are engineering living materials that can self-assemble, self-repair, and adapt to changing conditions. They're creating biological computers that process information using DNA. They're developing organisms that can manufacture complex chemicals more efficiently than any factory. Now imagine this technology refined over thousands of generations, Picture a civilization where buildings grew from specially engineered seeds, where transportation networks were living systems that moved people and goods through biological conduits, where information was stored and processed by organisms designed specifically for those purposes. Such a society could achieve things that would make our current technology look crude and wasteful. And when they were gone, their cities would simply decompose. Their transportation networks would return to the forest, and their computers would become indistinguishable from the plants and animals around them. The only traces left might be subtle improvements in soil quality, unusually healthy ecosystems, and maybe some genetic modifications in local species that we'd assume were the result of natural selection. Unless we knew exactly what to look for, we'd never realize we were looking at the remains of a technological civilization. But let's dig deeper into the geological evidence, because that's where things get really strange. Remember those chemical signatures I mentioned earlier? Well, it turns out there are more of them than most people realize, and they're not all easily explained by natural processes. In ice cores from Antarctica, scientists have found layers dating back hundreds of thousands of years that contain unusual concentrations of certain metals and synthetic compounds. The official explanation is usually volcanic activity or asteroid impacts, but some of these signatures don't quite match what we'd expect from those sources. There are carbon isotope spikes that suggest massive burning events, but at times when there's no evidence of widespread wildfires or volcanic eruptions. There are traces of rare earth elements in concentrations that seem almost impossible to achieve through natural processes. And there are isotope ratios of certain elements that look suspiciously like the byproducts of industrial activity. Now, I want to be clear here. I'm not saying these anomalies prove anything. Each individual case can probably be explained by some combination of natural factors we don't fully understand. But when you start looking at all of them together, a pattern emerges that's harder to dismiss. It's like finding a single footprint in the mud. Could be anything. Animal track, natural depression, random chance. But when you find a whole line of footprints leading somewhere specific, you start to suspect something was walking that path, even if you never see the creature that made them. And speaking of footprints, let me tell you about some discoveries that have been quietly troubling archaeologists for years. There are human footprints preserved in volcanic ash that appear to be much older than they should be. Stone tools found in geological layers that predate the supposed arrival of humans in certain regions by tens of thousands of years. Carved objects discovered in contexts that don't match our timeline of human development. Most of these findings are explained away or quietly filed under anomalous data pending further study. But they keep accumulating, each one individually explainable, but collectively forming a picture that doesn't quite fit the neat timeline we've constructed for human civilization. There's something else that's been bothering researchers, though it's rarely discussed in polite academic circles. The rate of human technological development doesn't follow a smooth curve. It's punctuated by sudden leaps that seem to come out of nowhere. Agriculture, for instance. For hundreds of thousands of years, humans were hunter-gatherers. Then, almost simultaneously in multiple locations around the world, different groups independently developed farming techniques. This happened in the Middle East, China, Mesoamerica, and other regions within a few thousand years of each other. That's an incredible coincidence in evolutionary terms. The same pattern appears with metallurgy, writing systems, astronomical knowledge, and complex mathematics. These innovations seem to emerge fully formed in different cultures that had no contact with each other. It's as if someone was distributing instruction manuals across the globe. Now, the standard explanation is that these were inevitable developments once humans reached a certain level of cognitive sophistication. But that explanation has always felt a bit unsatisfying. Why would inevitable developments take hundreds of thousands of years to appear, then suddenly manifest everywhere at once? What if these weren't independent inventions? What if they were rediscoveries? Knowledge that had existed before, been lost during some catastrophic period, and then gradually recovered as conditions became favorable again. This idea becomes more plausible when you consider how fragile knowledge really is. We think of information as permanent because we live in an age of books and digital storage. But for most of human history, knowledge was preserved through oral tradition, and oral tradition is incredibly vulnerable to disruption. A single generation of chaos, war, disease, or environmental catastrophe can sever the chain of cultural transmission. Knowledge that took centuries to accumulate can vanish in a matter of years. And once it's gone, future generations have to start over from scratch, slowly rediscovering principles that their ancestors once knew perfectly well. If this happened on a global scale, triggered by some planetary catastrophe around the end of the last ice age, it would explain why human civilization seems to restart so suddenly around 10,000 years ago. We might not be seeing the beginning of human achievement. We might be seeing the recovery from its greatest collapse. And this brings us to one of the most disturbing possibilities of all. What if the catastrophe that ended a hypothetical ancient civilization wasn't natural? What if they destroyed themselves? Advanced civilizations wield tremendous power, and power can be turned toward destruction just as easily as creation. We know this from our own experience. We've developed weapons capable of ending civilization, altered the planet's climate, and created forms of pollution that will persist for thousands of years. An ancient civilization might have faced similar challenges and handled them less successfully than we hope to. They might have triggered runaway climate change, poisoned their environment beyond recovery, or simply torn themselves apart through warfare using technologies we can barely imagine. If so, the chemical signatures we find in ancient ice cores might not be the traces of their industry. They might be the fingerprints of their destruction. The carbon spikes might mark the moment when their cities burned. The unusual isotope ratios might be the residue of weapons that made nuclear bombs look like firecrackers. This scenario is both terrifying and instructive. Terrifying because it suggests that intelligence doesn't guarantee survival, that reaching our level of technological capability might be more dangerous than we realize, but instructive because it might provide a roadmap for avoiding the same fate. If we could learn to recognize the signs of an ancient civilization's collapse in the geological record, we might be able to identify the mistakes that led to their destruction and avoid repeating them ourselves. Their failure could become our education, their catastrophe our warning. But there's another possibility that's even more intriguing. What if they didn't destroy themselves? What if they simply transcended the need for physical civilization as we understand it? This might sound like science fiction, but consider the trajectory of our own development. We're already moving toward digital existence in many ways. Virtual reality is becoming more immersive. Artificial intelligence is taking over more of our cognitive tasks. Brain-computer interfaces are allowing direct neural control of external devices. Now project that development forward not just decades, but millennia. Imagine a civilization that learned to upload consciousness into substrates more durable than biological brains. They might have achieved a form of immortality that made physical bodies obsolete, existing as pure information in crystalline matrices or quantum fields that we lack the sophistication to detect. From our perspective, such beings would be invisible. We'd find no cities because they no longer needed shelter, no tools because they had become their own tools, no transportation networks because they existed everywhere simultaneously. They might be around us right now, watching our clumsy attempts to understand our own past, amused by our assumption that intelligence must always express itself through crude matter. Or maybe they took a different path entirely. Maybe they learned to merge so completely with natural systems that they became indistinguishable from the planet itself. Their consciousness distributed through forest networks, their thoughts carried by wind patterns and ocean currents, their memories encoded in the genetic structures of every living thing. In this scenario, the Earth itself might be their legacy. Every ecosystem, every species, every natural process might be carrying out computations and storing information on scales we can't begin to comprehend. We might be living inside their technology without ever realizing it, like bacteria in a computer chip trying to understand the internet. These ideas push the boundaries of what we consider possible, I know, but that's exactly why they're worth considering. Throughout history, the most important discoveries have come from people willing to imagine possibilities that seemed absurd to their contemporaries. And here's what's really fascinating. The more we learn about consciousness, intelligence, and the nature of information, the less impossible these scenarios seem. We're discovering that intelligence can emerge from systems we never expected. That consciousness might be far more fundamental to the universe than we assumed. That information itself might be the basic building block of reality. If any of this is true, then our search for ancient civilizations has been looking in all the wrong places. We've been digging in the dirt for metal artifacts when we should be studying the deeper patterns that connect all life on Earth. We've been searching for monuments when we should be learning to read the language written in quantum fields and genetic codes. The evidence for such possibilities would be everywhere and nowhere. Everywhere because it would be woven into the fabric of reality itself. Nowhere because we lack the conceptual framework to recognize it as evidence of intelligence rather than natural law. This brings us full circle to the question that started this journey. Did an advanced civilization exist on Earth 100,000 years ago? The answer might be that we're asking the wrong question entirely. Maybe the real question is not whether they existed, but whether they ever left. Whether they're still here, so perfectly integrated with the natural world that we can't tell where nature ends and their influence begins. Whether every sunset we admire, every forest we walk through, every breath we take is part of a system designed by minds that learn to think on geological timescales. If so, then we're not just studying ancient history, we're trying to understand the present, and the implications of that understanding might change everything about how we see our place in the cosmos and our responsibility for the future of intelligence in the universe. But I'm getting ahead of myself. Before we can explore these cosmic possibilities, we need to look more closely at what we actually know about the deep past. And as it turns out, there are some specific pieces of evidence that deserve our attention. Strange artifacts, unusual geological formations, and genetic mysteries that might be trying to tell us something important about who we are and where we came from. Because if there's one thing this investigation has taught me, it's that the truth about our past might be far stranger, far more wonderful, and far more unsettling than anything we've dared to imagine. So let's talk about some of these strange artifacts and anomalies. Because once you start looking for them, they're everywhere. And I mean everywhere. The problem is, most people don't know to look, and when professional archaeologists do find something that doesn't fit, there's enormous pressure to explain it away rather than acknowledge that maybe our timeline is incomplete. Take the Antikythera mechanism. This was found in a shipwreck off the coast of Greece. And when researchers finally figured out what it was, it shattered their assumptions about ancient technology. This thing is a bronze computer, not a simple calculator, but a sophisticated astronomical device with dozens of interlocking gears that could predict the positions of planets, the timing of eclipses, and the cycles of Olympic Games decades into the future. The level of precision in its construction rivals the finest clockwork of the 18th century. Except it was built over 2,000 years ago, during a period when historians assured us that such technology was impossible. If we hadn't found this one miraculous example preserved in the oxygen-free environment of a shipwreck, we'd still believe that ancient Greeks were incapable of creating mechanical computers. Now, the Antikythera mechanism isn't 100,000 years old. It's maybe 2,000 years old. But here's what's terrifying about it. It's clearly not a first attempt. The sophistication of the design, the refinement of the gear ratios, the precision of the inscriptions, all of this suggests a mature technology with a long developmental history. Yet we have no evidence of that development, no prototypes, no simpler versions, no contemporary descriptions of how it was made. It's as if someone handed the ancient Greeks a blueprint for a device they shouldn't have been able to understand, let alone build. And that raises an uncomfortable question. How many other impossible technologies existed in the ancient world, but didn't happen to sink in exactly the right spot to be preserved for 2 millennia? This pattern repeats throughout archaeology. The precision of the pyramid construction, the astronomical alignments at Stonehenge, the massive stone blocks at Pumapunku, cut so precisely that you can't fit a razor blade between the joints. In each case, we're seeing evidence of capabilities that seem to appear fully formed, without the expected learning curve. But let's dig deeper into the really anomalous stuff, the artifacts that make archaeologists uncomfortable because they don't just challenge our timeline, they obliterate it. There's a metallic sphere found in South African mines, embedded in rock that's supposed to be 3 billion years old. The official explanation is that it's a natural formation, a concretion created by geological processes. But the thing has parallel grooves running around its circumference, grooves that look machined rather than natural. And it's made of a steel alloy that doesn't occur naturally anywhere on Earth. In Illinois, coal miners reported finding a bronze bell encased in a chunk of coal that formed millions of years before humans supposedly existed. The coal company kept the bell for a while, but it eventually disappeared into private collections. No scientific analysis was ever conducted, so we'll never know what it was really made of or how old it actually was. In Texas, workers found a human-made iron hammer embedded in limestone that geologists dated to over 100 million years old. The handle had partially fossilized, and the metal showed signs of a manufacturing process that includes elements we don't typically see in modern metallurgy. Skeptics argue that the dating is unreliable, that limestone can form around modern objects under the right conditions. And maybe they're right. But the pattern of these discoveries is what's intriguing, not any individual case. What we're seeing is a steady trickle of objects that shouldn't exist, found in contexts that don't make sense according to our current understanding of history. Most are dismissed, lost, or explained away. But they keep appearing, and each one raises the same uncomfortable question. What if our timeline is wrong? Now, I want to be clear about something. I'm not saying every anomalous artifact represents evidence of an ancient advanced civilization. Most of these objects probably have conventional explanations once they're properly studied. The problem is, they're rarely properly studied because they don't fit into the established narrative. There's a powerful bias in academic archaeology against findings that challenge the accepted chronology. Careers are built on incremental additions to existing knowledge, not on revolutionary discoveries that overturn everything we thought we knew. So when something genuinely anomalous turns up, the incentive is to find a way to make it fit the existing framework, rather than consider the possibility that the framework itself might be flawed. But here's where things get really interesting. Some of the most compelling evidence for ancient advanced technology isn't coming from controversial artifacts at all. It's coming from mainstream geology and climate science, from researchers who aren't looking for lost civilizations but keep finding signatures that don't quite make sense. Ice core data from Antarctica shows some fascinating anomalies. There are layers dating back over 100,000 years that contain unusual concentrations of certain metals and chemical compounds. The standard explanation involves volcanic activity and atmospheric chemistry, but some of these signatures are hard to explain through natural processes alone. For instance, there are spikes in industrial metals like lead and copper that predate any known mining activity by tens of thousands of years. There are traces of synthetic compounds that shouldn't exist in nature. And there are isotope ratios that look suspiciously like the byproducts of high-temperature industrial processes. Each individual anomaly can probably be explained by some combination of factors we don't fully understand. But when you look at them collectively, they form a pattern that's harder to dismiss. It's like finding traces of smoke in a forest where no fires are supposed to have burned. Ocean sediment cores tell a similar story. Layers from the late Pleistocene contain chemical signatures that suggest massive burning events, but at times when there's no evidence of widespread wildfires or volcanic eruptions. There are concentrations of rare earth elements that seem almost impossible to achieve through natural processes. And there are carbon isotope signatures that look like they could have come from large-scale fuel combustion. Now, before you get too excited, let me emphasize that these are subtle signals buried in enormous amounts of data. They're not smoking gun evidence of anything, but they represent the kind of traces that an industrial civilization might leave behind if it existed long enough ago that all physical evidence had been erased. And that brings us to one of the most intriguing aspects of this whole mystery: the timing. Most of these anomalous signatures cluster around specific periods in the geological record, periods that coincide with major climate changes, mass extinction events, and other planetary upheavals. The end of the last ice age is particularly interesting. This was a time of dramatic environmental change. When sea levels rose by hundreds of feet, vast areas of land disappeared beneath the waves, and the entire climate system reorganized itself. It was also the period immediately before the sudden appearance of agriculture and the first recognizable human civilizations. What if those weren't coincidences? What if the rise of our civilization was connected to the fall of another? What if the same climate changes that ended the Ice Age also destroyed an earlier advanced society, creating the conditions for a new one to emerge from the survivors? This scenario would explain some of the puzzling aspects of early human development. The sudden appearance of sophisticated knowledge in multiple fields, the simultaneous invention of similar technologies in different parts of the world, the existence of megalithic structures that seem to require organizational capabilities beyond what we'd expect from recently settled agricultural communities. But it also raises disturbing questions about stability and permanence. If an advanced civilization could rise and fall during the relatively recent geological past, what does that say about the long-term prospects for our own society? Climate records show that the Earth's environment is far less stable than we usually assume. Ice ages come and go. Ocean currents shift dramatically. Volcanic eruptions can alter global weather patterns for years at a time. And these natural cycles don't care about human timelines or technological achievements. An advanced civilization that developed during a stable climatic period might find itself completely unprepared for the kinds of environmental changes that Earth experiences over longer timescales. Their cities might be built in locations that become uninhabitable when ice sheets advance or retreat. Their agricultural systems might depend on weather patterns that shift without warning. Their entire technological infrastructure might become useless if sea levels rise or fall beyond certain thresholds. And here's the really unsettling part. We have no idea how resilient our own civilization would be to the kinds of environmental changes that have occurred repeatedly throughout Earth's history. We've never been tested by anything approaching a major ice age, a supervolcanic eruption, or the kind of sea level changes that happened at the end of the Pleistocene. We like to think our technology makes us immune to natural disasters, but that assumption might be dangerously naive. Our entire industrial system depends on complex supply chains, stable energy sources, and predictable environmental conditions. Disrupt any of those factors severely enough, and the whole thing could collapse faster than we imagine. If an ancient civilization faced similar vulnerabilities and failed to overcome them, their collapse might have been swift and total. Within a few generations, survivors could have found themselves living in a completely different world, with most of their ancestors' knowledge useless for the new conditions they faced. This brings us to one of the most important questions we can ask about any hypothetical ancient civilization. Not just whether they existed, but how they ended, because understanding their failure might be the key to avoiding our own. The geological record suggests that major environmental disruptions have triggered multiple waves of extinction and renewal throughout Earth's history. Each time conditions changed dramatically, some species thrived while others disappeared. Intelligence might provide certain advantages in adapting to change, but it's no guarantee of survival. In fact, intelligence might create its own vulnerabilities. Advanced civilizations tend to be highly specialized, dependent on complex technologies and social structures that can be fragile when subjected to unexpected stresses. A hunter-gatherer society might weather a climate change that would completely destroy an industrial civilization, simply because they're more adaptable and less dependent on fixed infrastructure. This paradox, that advancement might sometimes be a disadvantage in terms of long-term survival, could explain why we don't see more evidence of ancient civilizations. Maybe intelligence tends to create societies that are brilliant, but brittle, capable of remarkable achievements, but vulnerable to catastrophic failure when conditions change. If so, then our own civilization might be following a pattern that's played out before. We're reaching higher and higher levels of technological sophistication, but we're also becoming more and more dependent on systems we don't fully understand and can't easily replace if they fail. The question becomes whether we can learn to be both advanced and resilient, to develop technologies that enhance our capabilities without creating fatal vulnerabilities. And to answer that question, we need to understand what happened to those who came before us, if indeed anyone did, which brings us back to the evidence such as it is. Because despite all the anomalies and mysteries I've described, we still don't have definitive proof that an advanced civilization existed 100,000 years ago. We have hints, suggestions, patterns that might point in that direction. But we don't have anything that would convince a skeptical scientist or satisfy the burden of proof required for such an extraordinary claim. And maybe that's exactly what we should expect. Maybe the absence of clear evidence isn't a sign that nothing was there, but a sign that we're looking for the wrong things in the wrong places. Maybe we need to expand our definition of what constitutes evidence and our understanding of how intelligence might express itself across geological timescales. Because if there's one thing this investigation has taught me, it's that the universe is far stranger, far more complex, and far more mysterious than our current scientific frameworks can accommodate. And somewhere in that mystery, in the gaps between what we know and what we assume, there might be truths that could change everything about how we understand our place in the cosmos. The search for these truths isn't just an academic exercise, it's an existential necessity. Because if we're going to avoid the fate of hypothetical predecessors, we need to understand the forces that shape the rise and fall of civilizations on planetary timescales. We need to learn from successes and failures we can barely imagine, written in languages we're only beginning to decipher, and we need to do it quickly, because the clock is ticking. The same environmental and technological forces that might have challenged ancient civilizations are accelerating in our own time. Climate change, resource depletion, technological disruption, social complexity, reaching levels that might be unsustainable. If we're the first to reach this level of capability, then we're pioneers facing unprecedented challenges with no roadmap to guide us. If we're not the first, then somewhere in the deep history of our planet lie the records of others who face similar challenges. The question is whether we can learn to read those records before we're forced to write our own ending to the story. The trail of evidence, fragmentary and mysterious as it is, suggests that this story is far from over. In fact, we might just be getting to the most interesting part, where the mystery deepens and the implications of what we might discover become too significant to ignore. Because buried somewhere in the geological layers of our planet, encoded in the chemistry of ancient ice and the genetics of living organisms, there might be messages waiting for us. Messages from minds that thought thoughts we've never imagined, faced challenges we're only beginning to understand, and left behind clues that could guide us toward a future we can barely envision. The question is whether we're ready to receive those messages and whether we have the wisdom to understand what they're trying to tell us about the nature of intelligence, the fragility of civilization, and the deep patterns that connect all conscious beings across the vast expanses of space and time. The search for these cosmic messages leads us into territories that make even the most open-minded researchers uncomfortable. Because if we're serious about finding traces of a civilization that vanished 100,000 years ago, we need to look beyond the conventional archaeological toolkit. We need to think like detectives investigating a crime scene where almost all the evidence has been deliberately destroyed. And that's where things get genuinely unsettling. Because the more we learn about how Earth recycles its own surface, the more we realize that absence of evidence might be evidence of something else entirely. Not that nothing happened, but that whatever did happen was so thoroughly erased that we're essentially investigating a perfect crime committed by time itself. Let me walk you through what this kind of investigation actually looks like in practice. Imagine you're trying to prove that a city existed in a location where you now see only empty forest. The buildings are gone, have been ground to dust by. The roads are gone, even the foundations 100,000 years of weather. What do you look for? You look for what can't be destroyed. Changes in soil chemistry that persist long after the structures that caused them have vanished. Unusual concentrations of metals that don't occur naturally in those quantities. Isotope ratios that suggest artificial processes. Microscopic traces of synthetic materials that shouldn't exist in nature. This is exactly what researchers have been finding in locations around the world, though most don't realize the significance of what they're seeing. In the Amazon basin, soil samples contain traces of biochar and unusual nutrient distributions that suggest sophisticated agricultural techniques were used in areas we assumed were pristine wilderness. The patterns are so extensive and so precisely organized that they couldn't have been created by small-scale farming. In the Sahara Desert, ground-penetrating radar has revealed geometric structures buried beneath sand dunes, structures that appear to follow mathematical principles we associate with advanced engineering. The official explanation is that these are natural rock formations exposed by erosion. But the regularity of the patterns is difficult to explain through purely geological processes. Off the coast of Japan, underwater formations known as the Yonaguni Monument display what appear to be artificially carved steps, platforms, and passageways. Mainstream archaeology insists these are natural erosion patterns, but the precision of the angles and the complexity of the layout challenge that interpretation. If these structures are artificial, they would have been above water during the last ice age, when sea levels were much lower. Each of these discoveries can be explained away individually. Natural processes can create remarkably regular patterns. Erosion can carve shapes that look artificial. Chemical anomalies can result from volcanic activity or unusual geological conditions. But when you start mapping all these anomalies together, something interesting emerges. They cluster around specific time periods and specific geographical regions. The chemical signatures peak during the transition from the last ice age to the current interglacial period. The geometric structures appear most frequently in areas that would have been prime real estate during times of lower sea level. The soil anomalies concentrate in regions that would have supported large populations if the climate had been different. It's as if someone scattered puzzle pieces across the planet, and we're only now beginning to realize that they might fit together into a picture. We Never investigation takes a truly strange turn, some expected to see, but here's where the most compelling evidence isn't coming from archaeologists at all. It's coming from geneticists studying the human genome, and what they're finding doesn't match the neat timeline we've constructed for our own species development. Human genetic diversity shows patterns that suggest our population went through several severe bottlenecks, periods when the total number of humans alive dropped to dangerously low levels. The most recent of these bottlenecks occurred around 70,000 years ago, possibly triggered by the massive volcanic eruption at Toba in Indonesia. But here's what's strange. The genetic recovery from these bottlenecks happened faster than it should have. Populations that were reduced to a few thousand individuals somehow developed the knowledge and organizational skills necessary to spread across the entire planet within just a few tens of thousands of years. They went from nearly extinct to colonizing every habitable continent with remarkable speed. The standard explanation is that this represents the emergence of behaviorally modern humans, people with the same cognitive abilities we have today. But the speed of the expansion suggests they might have had help, not divine intervention, but access to knowledge that already existed. Maps, techniques, technologies that had been developed by earlier populations and somehow survived the catastrophe that nearly wiped them out. This possibility becomes more intriguing when you look at the distribution of certain genetic markers in modern human populations. Some of these markers appear to be much older than they should be, suggesting that they were inherited from populations that diverged from the main human lineage far earlier than our current models predict. There are also genetic sequences that seem to have been influenced by what researchers carefully call unknown archaic populations, groups of early humans or human relatives that contributed to our genetic makeup but left no fossil evidence of their existence. These ghost populations, as they're sometimes called, might have been the carriers of advanced knowledge that was passed down through interbreeding, rather than cultural transmission. If an advanced civilization had existed during the Middle Paleolithic, its survivors might not have maintained their technological capabilities, but they could have preserved certain kinds of knowledge in their genes. Not the instructions for building machines, but the cognitive and behavioral adaptations that made advanced civilization possible in the first place. This would explain some of the puzzling aspects of early human development. Why certain capabilities seem to appear suddenly in the archaeological record. Why similar innovations emerged independently in different parts of the world. Why humans were able to colonize diverse environments so quickly once they began expanding beyond Africa. We might be carrying the genetic legacy of minds that solved problems we're only now learning to tackle. The ability to think abstractly about complex systems. The capacity for long-term planning and coordination. The social intelligence necessary to maintain large-scale cooperative societies. These traits might not be recent innovations, but ancient adaptations that were refined over hundreds of thousands of years by populations whose physical remains have long since turned to dust. And if that's the case, then every time we solve a difficult problem, every time we have a breakthrough in science or technology, we might be rediscovering knowledge that was lost when their civilization fell, not copying their specific solutions, but following thought patterns that were encoded in our neural architecture by ancestors who faced similar challenges in a very different world. This idea transforms how we think about human potential. We're not just clever apes who recently stumbled onto the secrets of civilization. We might be the inheritors of an intellectual tradition that stretches back far deeper into time than we've ever imagined. The products of a selective pressure that favored the kinds of minds capable of building and maintaining complex societies across geological timescales. But if we're going to take this possibility seriously, we need to look at the other side of the equation. Not just how an ancient civilization might have succeeded, but how it might have failed, because understanding the mechanisms of collapse might be more important than understanding the achievements that preceded it. The fossil record shows us that mass extinctions are not anomalies in Earth's history. They're regular features of the planet's development, occurring roughly every 26 million years, with smaller extinction events happening much more frequently. Each time, the dominant species of the era are replaced by new forms of life that were previously marginal players in the ecosystem. Intelligence doesn't provide immunity from this process. In fact, it might make extinction more likely under certain circumstances. Intelligent species tend to modify their environment extensively, creating dependencies that can become fatal liabilities when conditions change. They also tend to develop complex social structures that can collapse catastrophically if the underlying systems that support them are disrupted. An advanced human civilization that existed during the last ice age would have faced challenges we can barely imagine. Dramatic climate shifts that could make entire regions uninhabitable within a few decades. Sea level changes that could flood coastal cities or strand ports hundreds of miles inland. volcanic eruptions that could block sunlight for years at a time and trigger global cooling. But the greatest threat might have come from their own success. Advanced civilizations consume resources at unsustainable rates, modify ecosystems beyond their capacity for recovery, and develop technologies that can have unintended consequences on planetary scales. The very capabilities that allowed them to thrive might have ultimately caused their destruction. We can see hints of this pattern in our own recent history. The rapid industrialization of the past few centuries has given us unprecedented power over our environment, but it's also created global problems that threaten the stability of the systems we depend on. Climate change, ocean acidification, biodiversity loss, pollution of air and water supplies. These are the byproducts of technologies that were developed to improve human life, but they might ultimately make human life impossible. An ancient civilization facing similar challenges might not have developed the scientific understanding necessary to recognize the long-term consequences of their actions until it was too late to change course. They might have triggered runaway processes that destroyed the environmental conditions their society required to function, or they might have simply run out of time. Earth's climate operates on cycles that dwarf human planning horizons. Ice ages begin and end according to astronomical cycles that unfold over tens of thousands of years. A civilization that developed during a stable interglacial period might have found itself completely unprepared for the onset of glaciation, especially if their population had grown beyond what the planet could support under Ice Age conditions. The survivors of such a collapse would face a world transformed beyond recognition, their cities buried under ice or drowned beneath rising seas, their agricultural systems useless in the new climate regime, their technologies dependent on resources that were no longer accessible. Within a few generations, they might have been forced to abandon everything their ancestors had built and return to the kind of subsistence existence that leaves few traces in the archaeological record. This scenario would explain one of the most puzzling aspects of human prehistory: the apparent gap between our species' intellectual potential and our actual achievements for most of our existence. If we've been capable of developing advanced civilization for hundreds of thousands of years, why did we wait so long to actually do it? Maybe we didn't wait. Maybe we tried multiple times, succeeded for a while, then failed catastrophically enough that we had to start over from the beginning. Each collapse would reset the clock, forcing survivors to redevelop basic technologies and social institutions before they could even begin to approach the complexity their predecessors had achieved. From this perspective, our current civilization isn't humanity's first attempt at technological society. It's our most recent attempt, built on the ruins of earlier experiments that we've forgotten so completely we don't even realize they happened. And if that's true, then the stakes of our current challenges are even higher than we thought. We're not just risking the future of human civilization, we're risking the loss of everything our species has learned through multiple cycles of rise and fall. All the knowledge, all the wisdom, all the hard-won understanding that might have accumulated over hundreds of thousands of years of trying to build sustainable societies. This brings us to one of the most profound questions we can ask about our place in cosmic history. Are we alone in facing these challenges, or are we part of a pattern that plays out wherever intelligence emerges in the universe? The Fermi paradox asks why we haven't encountered evidence of extraterrestrial civilizations, given the vast number of potentially habitable planets in our galaxy. One possible answer is that advanced civilizations tend to destroy themselves or face insurmountable environmental challenges before they develop the capability for interstellar communication or travel. If intelligent species regularly go through cycles of rise and collapse on their home planets, then the universe might be full of worlds where technological civilizations have emerged multiple times, only to fade back into prehistory when they couldn't solve the fundamental problems of sustainable development. Earth itself might be just one example of this pattern, a planet where intelligence has emerged repeatedly but struggled to maintain itself across the geological timescales necessary for true permanence, we might be surrounded by the ruins of our own previous attempts at civilization, ruins so ancient and so thoroughly recycled by natural processes that we can barely recognize them as artificial. This possibility is both humbling and terrifying. Humbling because it suggests that our current achievements, impressive as they seem to us, might be just the latest iteration of a story that's been told many times before. Terrifying because it implies that the problems we're facing, climate change, resource depletion, technological disruption, might be more fundamental than we realized. Maybe these aren't unique challenges created by our particular form of industrial development. Maybe they're inevitable consequences of intelligence itself, problems that any sufficiently advanced species must eventually confront. The test that determines whether a civilization survives long enough to reach the stars or joins the ranks of the forgotten. If so, then our success or failure won't just determine the future of humanity. It will determine whether intelligence on Earth finally breaks free from the cycle of rise and collapse that might have trapped it for hundreds of thousands of years. But here's the thing that gives me hope. If previous civilizations did exist and did fail, they might have left behind more than just chemical traces and genetic memories. They might have left behind lessons, encoded in the very structure of the world they bequeathed to us. Every ecosystem we study, every natural process we try to understand, every pattern we discover in the complexity of life on Earth might be carrying information about sustainable ways of living that were learned through bitter experience by minds that came before us. The solutions to our current problems might already exist, written in the language of biology and ecology, by civilizations that learned too late what we're only beginning to understand. Our task isn't to reinvent sustainable civilization from scratch. It's to learn to read the instruction manual that might already be embedded in the world around us, left behind by predecessors who faced the same challenges we're facing now and found ways to live in harmony with planetary systems across timescales that dwarf individual lifetimes. The evidence for this possibility exists all around us if we know how to look for it, in the self-regulating mechanisms that keep Earth's climate stable across geological time, in the complex networks of cooperation and competition that allow ecosystems to persist through dramatic environmental changes, in the genetic codes that preserve information across millions of years of evolution. We're not just studying nature when we investigate these systems. We might be studying technology, the ultimate expression of intelligence that learned to work with natural processes instead of against them. Technology so sophisticated that it became indistinguishable from the environment itself. And maybe that's the real message waiting for us in the deep history of our planet. Not that intelligence inevitably fails, but that it can succeed in ways we haven't yet imagined. Ways that don't require leaving massive monuments or creating permanent scars on the landscape. Ways that enhance the complexity and resilience of the systems they touch, instead of simplifying and destroying them. The search for ancient civilizations might ultimately be a search for better ways of being civilized, and the answers we find might determine not just whether we survive the next 100 years, but whether we finally break free from the cycles of rise and collapse that have defined the history of intelligence on Earth. Because somewhere in the space between what we know and what we're afraid to imagine, there might be truths that could transform everything about how we understand our relationship with this planet and our responsibility for its future. Truths that are written not in stone monuments or metal artifacts, but in the deeper patterns that connect all life across the vast expanses of time. The question is whether we're ready to receive those truths, and whether we have the wisdom to apply them before we become another mysterious chapter in the geological record, leaving future civilizations to wonder what we might have achieved if we'd only learned to read the messages that were right in front of us all along. The deeper we dig into this possibility, the more we realize that our entire approach to understanding the past might be fundamentally backwards. We've been looking for what survived when we should be looking for what couldn't survive. We've been searching for permanence in a world that specializes in erasure. Think about it this way. If you wanted to hide something from future archaeologists, what would be the most effective method? You could bury it deep underground, but they might dig it up. You could seal it in a vault, but they might break in. You could scatter it across the ocean floor, but they might eventually develop the technology to explore those depths. But there's one hiding place that's absolutely perfect: time itself. Not just a few thousand years, but deep time. Geological time. The kind of time that turns mountains into sand and continents into memories. And here's what's genuinely unsettling about this realization. The absence of evidence from 100,000 years ago isn't just consistent with nothing having happened. It's exactly what we'd expect if something extraordinary had happened and then been systematically erased by the most thorough cleaning service in the universe. Every day, every hour, every minute, the Earth is actively destroying its own history. Rivers carry away sediment that might contain artifacts. Tectonic plates slide past each other, grinding ancient surfaces into unrecognizable fragments. Ice ages advance and retreat like cosmic bulldozers, scraping entire landscapes clean and depositing the debris hundreds of miles away. Even the air we breathe is complicit in this conspiracy of forgetting. Oxygen corrodes metal, breaks down organic compounds, and slowly dissolves even the hardest stone. What we call weathering is really just chemistry's way of ensuring that nothing lasts forever. But here's where it gets interesting. While this process destroys almost everything, it doesn't destroy everything equally. Some things are more resistant to erasure than others, and if we're smart about it, we can use these differential survival rates to reconstruct what might have been there originally. It's like being a detective at a crime scene, where the perpetrator has tried to destroy all the evidence. You can't find fingerprints or DNA, but you can find traces of the cleaning agents they used to eliminate the fingerprints and DNA. The absence of evidence becomes evidence of the attempt to create that absence. In the geological record, this translates to looking for the signatures of destruction rather than the signatures of creation. Instead of searching for ancient buildings, we look for unusual concentrations of building materials in places where no natural process should have concentrated them. Instead of hunting for ancient tools, we search for the chemical residues left behind when those tools corroded away. And when you start looking at the data this way, some very strange patterns emerge. There are locations around the world where soil samples show massive spikes in certain metals during specific time periods. Iron, copper, aluminum, rare earth elements, all concentrated in quantities that would require industrial-scale processing to achieve. The standard explanation involves natural ore deposits and unusual weathering patterns, but the timing is suspicious. These spikes cluster around the end of the last ice age, exactly when you'd expect to find evidence of a civilization that was destroyed by the dramatic climate changes of that period. It's as if someone had been mining and processing these materials on a massive scale, then suddenly stopped around 50,000 years ago. Ocean sediment cores tell a similar story. Deep beneath the waves, in layers that formed during the late Pleistocene, researchers have found microscopic particles that look suspiciously like industrial byproducts. Tiny spheres of metal and glass that form when materials are subjected to extremely high temperatures. Crystalline structures that don't occur naturally, but match what we'd expect from advanced manufacturing processes. Each individual discovery can be explained away. Meteorite impacts can create high-temperature particles. Volcanic eruptions can produce unusual crystalline formations. Natural processes can concentrate metals in surprising ways. But the cumulative effect is harder to dismiss. It's like finding smoke residue in a forest where no fires are supposed to have burned, ash deposits where no volcanoes exist, and flood marks where no rivers flow. Individually explainable, collectively suggestive of something that doesn't fit our current understanding of what should have been happening in those places, at those times. But perhaps the most intriguing evidence comes from an unexpected source. The DNA of modern humans carries within it a record of our species' history that goes back far deeper than any archaeological site. And hidden in that genetic code are some very puzzling patterns. Population genetics tells us that modern humans went through several severe bottlenecks, periods when our total numbers dropped to dangerously low levels. The most severe of these occurred around 70,000 years ago, possibly triggered by the massive volcanic eruption at Toba in Indonesia. But here's what's strange about our recovery from these near-extinction events. We bounced back too quickly. Populations that had been reduced to a few thousand individuals somehow developed the knowledge and organizational skills necessary to colonize the entire planet within just tens of thousands of years. They went from nearly extinct to successfully adapting to every environment from Arctic tundra to tropical rainforests, with a speed that defies explanation. The Standard Model suggests this represents the emergence of behaviorally modern humans, people with the same cognitive abilities we have today. But the speed of the expansion and the sophistication of the technologies that appear in the archaeological record suggest they might have had access to knowledge that already existed, not necessarily high technology in the way we understand it, but deep understanding of natural systems, survival techniques, and organizational methods that had been developed over much longer periods by previous populations. Knowledge that survived the catastrophes that destroyed the physical infrastructure of earlier civilizations. This possibility becomes even more intriguing when you look at the genetic signatures of these bottleneck events. They don't show the random patterns you'd expect from natural disasters affecting a primitive population. Instead, they show evidence of selective survival that preserved specific genetic lineages while others disappeared completely. It's as if someone was choosing which populations would survive and which would perish, based on criteria we can't fully understand. Maybe it wasn't intentional selection. Maybe it was just that certain groups had access to knowledge or resources that gave them an advantage during the crisis. But the pattern suggests that the survivors weren't random refugees from a collapsing primitive society. They were the inheritors of something more complex, carrying forward not just their genes, but their understanding of how to rebuild civilization from the ground up. And they did rebuild it, faster and more successfully than should have been possible for people starting from zero. This genetic evidence is supported by something equally puzzling in the archaeological record. The technologies that appear suddenly in different parts of the world during the Upper Paleolithic aren't crude first attempts at innovation. They're sophisticated solutions to complex problems, implemented with a level of skill that suggests long developmental histories. The cave paintings at Lascaux and Altamira aren't primitive scratchings on rock walls. They demonstrate advanced understanding of artistic technique, sophisticated use of natural pigments, and complex symbolic thinking. The people who created them weren't struggling to express themselves with limited means. They were working within established traditions of visual representation that required generations to develop. The megalithic structures that begin appearing around the same time show similar sophistication. Stonehenge, Göbekli Tepe, the stone circles of Scotland, these aren't the first attempts of people learning to work with large stones. They're the products of mature engineering traditions that knew how to quarry, transport, and precisely position massive blocks using techniques we still don't fully understand. And here's what's most puzzling of all. These sophisticated technologies appear suddenly in the archaeological record, flourish for a few thousand years, then often disappear just as suddenly. It's as if people periodically remembered how to do complex things, implemented them successfully, then forgot again. This pattern of knowledge appearing, disappearing, and reappearing is exactly what you'd expect if civilization had been going through cycles of rise and collapse for much longer than we currently realize. Each recovery period would see survivors trying to reconstruct what their ancestors had known, succeeding partially, then losing the knowledge again when the next crisis hit. But there's another possibility that's even more intriguing. What if the knowledge never really disappeared? What if it was preserved in forms we don't recognize as technological, embedded in cultural practices, oral traditions, and genetic memories that could be activated when conditions became favorable for rebuilding complex societies. This brings us to one of the most fascinating aspects of human culture: the universality of certain concepts, symbols, and practices across completely separated populations. Every human society develops mathematics, astronomy, medicine, and complex social organization, often following remarkably similar patterns despite having no contact with each other. The standard explanation is that these are inevitable products of human intelligence working on universal problems. But what if they're not innovations at all? What if they're memories, cultural DNA that preserves the essential knowledge needed to rebuild technological civilization whenever it collapses? From this perspective, every time we rediscover a scientific principle, every time we reinvent a useful technology, every time we develop a new form of social organization, we might be following pathways that were established long ago by minds that face the same challenges we're facing now. The mathematical relationships we call natural laws might be natural not because they're inherent properties of the universe, but because they're the solutions that any sufficiently advanced intelligence will eventually discover when trying to understand how reality works. The technologies we think of as modern innovations might be the inevitable endpoints of developmental processes that have been repeated multiple times throughout human history. And the social institutions we've created to manage complex societies, governments, economies, educational systems might all be variations on organizational templates that were refined over hundreds of thousands of years by civilizations that learned through trial and error what works and what doesn't. If this is true, then we're not pioneers exploring unknown territory. We're travelers following ancient paths, guided by signposts left behind by predecessors, whose journeys we've forgotten, but whose destinations we're still trying to reach. This reframes everything about how we think about human progress and potential. We're not the first to face the challenges of building sustainable, complex societies. We might not even be the 10th or 20th. We might be the latest in a long series of attempts, each building on the lessons learned by previous iterations, each trying to solve problems that have been testing intelligence on this planet for far longer than we've dared to imagine. But here's what makes this possibility both hopeful and terrifying. If we're following in the footsteps of predecessors, then somewhere ahead of us on the path are the places where they stumbled and fell, the mistakes that brought down civilizations we can't remember, the traps that intelligence has fallen into repeatedly throughout deep history. Understanding these failure modes might be more important than understanding the achievements that preceded them. Because if we can identify the patterns that lead to collapse, we might be able to break free from the cycle that has apparently been repeating for hundreds of thousands of years. The evidence suggests that the greatest threat to advanced civilizations isn't external catastrophe, though that certainly plays a role. It's the internal contradictions that develop when intelligence becomes too successful for its own good. When societies become so complex that they can't adapt to changing conditions. When technologies become so powerful that their unintended consequences overwhelm the systems they were designed to support. Every mass extinction in Earth's history has been followed by a period of rapid evolution and diversification. The species that survive catastrophic changes are usually not the dominant ones from the previous era. They're the adaptable ones, the generalists, the organisms that can thrive in multiple environments, rather than being perfectly suited to one specific niche. Intelligence might face the same evolutionary pressure. Highly specialized, technologically advanced civilizations might be vulnerable to exactly the kinds of environmental and social disruptions that more flexible, resilient societies could weather successfully. This suggests that the key to long-term survival isn't developing more powerful technologies or building more complex institutions. It's learning to maintain the adaptability and resilience that allowed our species to survive previous catastrophes, while also preserving the knowledge and capabilities that make technological civilization possible. It's a delicate balance, and one that previous iterations of human civilization might have struggled to achieve. Too much specialization leads to brittleness. Too little leads to stagnation. Finding the sweet spot between advancement and adaptability might be the ultimate test of intelligence. And maybe that's the real message waiting for us in the deep history of our planet. Not instructions for building better technologies, but wisdom about how to build better relationships between intelligence and the natural systems that support it. How to be advanced without being fragile. How to be complex without being chaotic. The answers to these questions might already exist, encoded in the patterns of survival and recovery that have played out on Earth for hundreds of thousands of years, written not in stone monuments or metal artifacts, but in the deeper structures of ecosystem dynamics, genetic adaptation, and cultural evolution. Our task isn't to solve these problems from scratch. It's to learn to read the instruction manual that evolution has been writing through countless cycles of rise and fall, success and failure, adaptation and extinction. The manual that might contain the keys to finally breaking free from the patterns that have limited intelligence on this planet for far too long. Because if there's one thing this investigation has convinced me of, it's that we're part of something much larger and more significant than we usually allow ourselves to believe. Whether we're the first technological civilization or the latest in a long series, we're participating in one of the universe's most ambitious experiments. The attempt to create forms of intelligence stable enough to persist across geological timescales. The stakes couldn't be higher, not just for us, but for the entire project of consciousness in the cosmos. If we succeed, we might finally establish intelligence as a permanent feature of Earth's biosphere. If we fail, we might just be adding another chapter to a story of brilliant promise repeatedly cut short by the fundamental challenges of being smart in a complex, ever-changing universe. The choice, as far as we can tell, is ours. But the consequences will echo far beyond our own species and our own time, into futures we can barely imagine and pasts we're only beginning to remember. The weight of this possibility settles over you slowly, like dust accumulating on surfaces you thought were clean. We've spent this entire investigation dancing around the edges of something that might fundamentally alter how we understand our place in the cosmic story. But now we need to confront the implications head-on, because they're not just academic curiosities. They're urgent questions about survival, legacy, and the nature of intelligence itself. If previous civilizations did exist and did fall, we're not just inheritors of their genetic code and cultural memories. We're participants in an ongoing experiment that spans geological time. An experiment in whether consciousness can learn to persist across the kinds of timescales that dwarf individual lifetimes, species lifetimes, even the lifetimes of entire ecosystems. And here's what should keep you awake at night. The experiment might be failing. Repeatedly. Consider the mathematics of deep time for a moment. If technological civilizations have been emerging and collapsing on Earth for hundreds of thousands of years, then the pattern we're seeing isn't random. It's systematic. There's something about the relationship between intelligence and planetary systems that creates recurring instabilities. Something that causes even the most advanced societies to eventually exceed their environmental carrying capacity or trigger changes they can't adapt to. This isn't speculation anymore. We can see it happening in our own time. Climate systems destabilizing faster than predicted. Biodiversity collapsing at rates that rival mass extinction events. Social and economic institutions struggling to cope with technological changes that outpace their ability to adapt. We're experiencing in real time the kinds of systemic stresses that might have brought down our predecessors. But we're also experiencing something they might not have had. The ability to study the problem while it's happening. To recognize the patterns while we're still caught in them. To potentially break free from cycles that have been playing out unconsciously for longer than we've been keeping track. The geological record, fragmentary as it is, might be trying to warn us about something. Those chemical signatures clustering around periods of environmental upheaval. those isotope ratios that suggest industrial activity followed by sudden collapse. Those genetic bottlenecks that reduced human populations to tiny refugia populations before mysterious recoveries. What if these aren't just random catastrophes? What if they're the predictable consequences of intelligence reaching certain thresholds of environmental impact? The signatures of civilizations that grew too fast, consumed too much, and altered their planetary environment beyond the point of stability. From this perspective, the absence of clear archaeological evidence from previous civilizations isn't a mystery. It's a warning. It tells us that whatever they built, however advanced they became, it wasn't sustainable enough to survive the consequences of its own success. And that brings us to the most important question we can ask about our current situation. Are we making the same mistakes they made? Are we following the same developmental pathways that led to their destruction? Or have we learned enough about planetary systems and the long-term consequences of technological development to choose a different path? The answer isn't clear, but the trajectory is troubling. We're altering Earth's chemistry faster than any previous civilization could have managed. We're depleting resources, disrupting ecosystems, and triggering feedback loops in the climate system that might be impossible to reverse. We're doing this with full knowledge of the consequences, yet seemingly unable to change course quickly enough to prevent catastrophic outcomes. It's as if we're trapped in a pattern that's stronger than individual choice or national policy, a pattern that emerges from the fundamental dynamics of how intelligence interacts with finite resources on a closed planetary system. The same pattern that might have trapped every previous iteration of technological civilization. But here's where the story takes an unexpected turn. Because if we're caught in a repeating cycle, then we're not just victims of that cycle. We're also its products. Everything about us, our cognitive abilities, our social instincts, our capacity for innovation and adaptation, has been shaped by hundreds of thousands of years of surviving and recovering from civilizational collapse. We might be evolution's answer to the sustainability problem. Not the first attempt at creating stable technological intelligence, but the latest iteration in a long series of experiments, each one refined by the lessons learned from previous failures. Our brains didn't evolve just to hunt animals and gather plants. They evolved to rebuild complex societies from the fragments left behind by previous collapses, to preserve essential knowledge through dark ages, to recognize patterns that repeat across timescales longer than individual memory, to solve problems that our ancestors faced repeatedly but never quite mastered. From this perspective, every challenge we're facing now becomes both more daunting and more hopeful. More daunting because we're not dealing with unique problems that clever engineering can solve. We're confronting fundamental tensions between intelligence and sustainability that have been testing consciousness on this planet for far longer than we've realized. But more hopeful because we're not starting from scratch. We're the inheritors of countless experiments in living sustainably on a finite planet. The solutions we need might already exist, embedded in the deep structures of how life organizes itself across multiple scales of space and time. The question becomes whether we can learn to read those solutions before we're forced to become another data point in the long experiment, another civilization that rose high enough to glimpse the possibilities of intelligence, then fell far enough to reset the entire process. And that brings us to something that might be the most important realization of this entire investigation. The search for ancient civilizations isn't really about the past at all. It's about the future, about understanding the constraints and possibilities that shape the long-term trajectory of intelligence in the universe. If we're alone in having reached this level of technological capability, then we're pioneers facing unprecedented challenges with no roadmap to guide us. If we're not alone, then we're part of a much larger story about the relationship between consciousness and the cosmos. A story that's been playing out on countless worlds around countless stars for billions of years. Either way, our choices matter more than we've ever imagined. Not just for our own species or our own planet, but for the entire project of intelligence in the universe. We might be carrying forward the accumulated wisdom of countless previous attempts at creating sustainable technological civilization. Or we might be the first to face these challenges and the first to either succeed or fail. The responsibility is staggering, and it makes every decision we make about energy, environment, technology, and social organization part of a much larger conversation about what intelligence can become when it learns to work in harmony with the natural systems that created it. But there's one more layer to this story that we need to explore. Because if advanced civilizations have risen and fallen on Earth before, they might have left behind more than just chemical traces and genetic memories. They might have left behind infrastructure. Not the kind we'd recognize as buildings or machines, but modifications to planetary systems themselves. Changes so fundamental and so well integrated with natural processes that we've never recognized them as artificial. Think about how we're already beginning to modify Earth's climate, atmosphere, and biosphere, not intentionally in most cases, but as inevitable consequences of industrial activity. Now imagine a civilization that learned to make such modifications deliberately, with full understanding of the long-term consequences and the wisdom to create changes that would enhance rather than degrade planetary stability. Such a civilization wouldn't leave behind ruins, it would leave behind improvements, ecosystems that function more efficiently than they would naturally, climate regulation systems that maintain optimal conditions across longer timescales, genetic modifications that increase the resilience and adaptability of life itself. We might be living inside their technology right now, surrounded by engineering projects so sophisticated and so perfectly integrated with natural systems that we can't tell where nature ends and artificial design begins. The oxygen we breathe, produced by photosynthesis in quantities that seem almost perfectly calibrated to support complex life. The carbon cycle that regulates planetary temperature within the narrow range compatible with liquid water. The magnetic field that protects the atmosphere from solar radiation. The plate tectonics that recycle nutrients and prevent the buildup of toxic materials in the biosphere. All of these systems show signs of what engineers call robust design. They're not just functional, they're resilient. They maintain stability across vast ranges of perturbation. They have backup systems and feedback loops that prevent catastrophic failure. They show the hallmarks of intelligence applied to the problem of creating sustainable conditions for life across geological timescales. Maybe that's what true technological advancement looks like. Not the ability to build machines that dominate natural systems, but the wisdom to enhance natural systems until they become indistinguishable from the most sophisticated technology imaginable. Technology that improves with age instead of degrading. That becomes more efficient over time instead of less. That creates abundance instead of scarcity. If previous civilizations achieved this level of integration with planetary systems, then their greatest legacy wouldn't be monuments to their intelligence. It would be the living world itself. Every forest, every ocean, every breath of air would be a testament to minds that learn to think like planets, to plan like ecosystems, to build like evolution itself, and we would be both their inheritors and their creation. Products of a world shaped by intelligence operating on timescales so vast that its interventions became indistinguishable from natural law. This possibility transforms everything about how we understand our relationship with the environment. We're not separate from nature, struggling to find ways to live in harmony with systems we didn't create. We might be nature, the latest expression of intelligence that's been shaping this planet's development for hundreds of thousands of years. Our technologies aren't violations of natural principles. They're attempts to continue the work of integration and optimization that began long before we were conscious of participating in it. Every time we develop a more efficient energy system, create more resilient social institutions, or find ways to enhance rather than degrade the ecosystems we depend on, we might be following design principles established by minds we can't remember but whose influence surrounds us constantly. The question isn't whether we can learn to live sustainably on this planet. The question is whether we can learn to recognize and continue the sustainable development project that might already be underway. Whether we can become conscious participants in an engineering effort that spans geological time and operates at planetary scales. And that's where this investigation ultimately leads us, not to definitive answers about whether ancient civilizations existed, but to a fundamental reframe of what civilization means in the first place. Maybe civilization isn't about building things that last. Maybe it's about building things that improve over time. Not monuments to human achievement, but contributions to planetary intelligence. Not technologies that separate us from nature, but technologies that help us become more natural than we ever imagined possible. The search for our predecessors becomes a search for our potential. The question of whether we're alone becomes a question of whether we're ready to join a conversation that's been going on for far longer than we've been listening. A conversation between intelligence and the universe about what consciousness can become when it learns to think beyond the timescales of individual existence. And in that conversation, every choice we make about how to live, how to build, and how to relate to the natural world becomes a message to future minds. A signal about whether intelligence on Earth is finally ready to graduate from the cycles of rise and collapse that have limited its expression for so long. The evidence, fragmentary as it remains, suggests that graduation is possible, that consciousness can learn to persist across geological time, that the experiment we're all part of might finally be approaching success. But success requires understanding the full scope of what we're attempting, not just building a civilization that can survive the next century, but participating in the creation of planetary intelligence that can guide the development of life and consciousness across the vast expanses of cosmic time. We might be closer to that goal than we realize. And we might have more help from sources we're only beginning to recognize than we've ever dared to hope. The story of ancient civilizations isn't ending with this investigation. It's just beginning. Because we're not just studying the past anymore. We're actively creating the future that future minds will study when they ask the same questions we're asking now. And the answers they find will depend on the choices we make in the brief span of time we have to influence the trajectory of intelligence on this ancient, patient, endlessly creative planet we call home. The circle closes where it began, with questions that change us in the asking, with mysteries that teach us more about ourselves than any answer ever could, with the recognition that in searching for who came before us, we might be discovering who we're meant to become. And that transformation, quiet as it is, might be the most important archaeological discovery of all. Not artifacts buried in the ground, but possibilities buried in consciousness itself, waiting for the right moment, the right conditions, the right combination of wisdom and courage to finally emerge into the light. The investigation continues, in laboratories and libraries, in the field and in the imagination, in the space between what we know and what we're brave enough to consider. Because somewhere in that space, the future is being written by minds that remember more than they realize and dream of, more than they can yet achieve. The search for ancient civilizations becomes the search for ancient wisdom, and ancient wisdom, it turns out, might be the only thing that can guide us safely into the deep future that awaits us all. But that's just the beginning of what this investigation reveals. Because if we're serious about finding traces of intelligence from 100,000 years ago, we need to look beyond our own planet entirely. We need to consider the possibility that consciousness itself might be far more common in the universe than we've ever imagined, and that Earth might have been a meeting ground for minds that originated in very different places under very different circumstances. The Drake equation attempts to estimate how many communicating civilizations might exist in our galaxy. Most calculations suggest there should be thousands, maybe millions of worlds where intelligence has emerged. Yet we see no signs of them. No radio signals, no obvious megastructures, no visitors arriving to shake our hands and welcome us to the cosmic community. This absence has puzzled scientists for decades. It's called the Fermi paradox, and it asks a simple question that has no simple answer. If the universe should be teeming with intelligent life, where is everybody? One possibility is that we're looking in the wrong places and at the wrong scales. We expect alien civilizations to announce themselves with radio broadcasts or massive engineering projects. But what if advanced intelligence learns to communicate through methods we can't detect? What if it operates on timescales so vast that our entire recorded history is just a fleeting moment in their conversations? Consider how we might appear to a mayfly, an insect that lives for a single day. Our movements would be so slow as to be nearly imperceptible. Our technologies would seem like unchanging features of the landscape. Our cities might as well be mountains, for all the mayfly could understand about their purpose or origin. Now imagine intelligence that operates on geological timescales. Beings whose thoughts unfold over millennia, whose conversations span ice ages, whose projects take millions of years to complete. To such minds, our entire civilization might be nothing more than an interesting fluctuation in atmospheric chemistry, a brief spike in radio emissions that appears and disappears faster than they can focus their attention. If such intelligences exist, they might have been present on Earth long before humans evolved, not as visitors from other planets, but as native expressions of consciousness that emerged from terrestrial conditions we can't even imagine. Forms of awareness so different from ours that we lack the conceptual framework to recognize them as intelligent at all. This brings us to something that's been quietly troubling researchers in multiple fields. The more we study complex systems, whether they're ecosystems, weather patterns, or even the behavior of subatomic particles, the more they seem to exhibit properties that look suspiciously like purposeful organization. Forest networks that share resources and information across vast distances. Ocean currents that regulate global climate with precision that rivals our most sophisticated engineering. Quantum systems that seem to process information and make decisions in ways that blur the line between physics and computation. We call these phenomena emergent properties of complex systems. But emergence might just be our word for intelligence we don't know how to recognize. What we interpret as natural law might actually be the operating principles of minds so vast and so thoroughly integrated with physical reality that we mistake their thoughts for the fundamental structure of the universe. If this sounds like mysticism, consider what we already know about consciousness and its relationship to physical systems. The human brain processes information using the same principles that govern weather patterns, ecosystem dynamics, and the behavior of galaxies. There's no clear boundary between mind and matter at the quantum level, where observation itself seems to influence the behavior of particles. Maybe consciousness isn't something that emerges from matter under rare and special conditions. Maybe consciousness is a fundamental property of reality itself, expressing itself wherever conditions allow sufficient complexity and organization to develop. From this perspective, Earth isn't a lonely outpost of intelligence in an empty universe. It's one manifestation of cosmic consciousness, a particular expression of the universe's capacity for self-awareness and self-organization. And human intelligence isn't unique or separate from this larger process. We're participants in it, temporary concentrations of awareness within a much vaster network of mind. This possibility transforms how we think about the search for ancient civilizations. We're not just looking for evidence of other humans or human-like beings who developed technology before us. We're looking for traces of intelligence that might have taken forms we've never considered. What if consciousness on Earth has been experimenting with different ways of organizing itself for billions of years? What if biological evolution is just one method among many for creating increasingly sophisticated forms of awareness? What if there have been civilizations based on crystalline structures, plasma formations, or even patterns of quantum entanglement that persist across cosmic distances? Such intelligences wouldn't leave behind stone tools or metal artifacts. They might not even have what we recognize as individual bodies or discrete lifespans. Their traces would be written in the fundamental constants of physics, the organizational principles of chemistry, the deep patterns that govern how complexity emerges from simplicity across all scales of space and time. We might be surrounded by the archaeological remains of minds that learn to encode themselves in the basic laws of reality. Every equation we discover, every natural principle we identify, might be a message left behind by intelligences that achieved the ultimate form of permanence, not by building monuments that resist time, but by becoming time itself. This brings us to one of the most profound implications of our investigation. If ancient civilizations did exist, if they found ways to persist across geological timescales, they might still be here. Not as ghosts haunting ruins we can't find, but as active participants in the ongoing development of consciousness on this planet. Every breakthrough we make in science might be guided by influences we can't perceive. Every creative insight, every moment of inspiration, every leap of understanding that seems to come from nowhere might actually come from somewhere we haven't learned to look. We think of ourselves as isolated individuals, struggling to make sense of an indifferent universe. But what if we're actually nodes in a vast network of intelligence that spans not just space, but time as well? What if every human mind is connected to a larger consciousness that includes not just our contemporaries, but the accumulated wisdom of every intelligence that has ever existed on this planet? The evidence for such connections exists in ways we're only beginning to understand. Identical innovations appearing simultaneously in different parts of the world. Scientific discoveries made independently by researchers who had no contact with each other. Mathematical truths that seem to be discovered rather than invented, as if they existed independently of the minds that found them. Jung called this the collective unconscious, a shared repository of human experience and wisdom that transcends individual psychology. But maybe it's more than metaphor. Maybe it's a literal description of how consciousness operates across multiple scales of time and space. If previous civilizations learned to tap into this deeper level of awareness, they might have found ways to preserve their essential knowledge even after their physical forms disappeared. Not in books or computers, but in the structure of consciousness itself. In the patterns of thought and creativity that guide intelligence wherever it emerges. This would explain some of the most puzzling aspects of human development. Why we seem to have capabilities far beyond what survival in primitive conditions would require. Why we're drawn to create art, music, and poetry that serves no obvious evolutionary purpose. Why we have intuitive understanding of mathematical relationships that exist independently of physical reality. We might not be primitive beings slowly climbing toward intelligence. We might be the latest expression of intelligence that's been evolving on this planet for far longer than we've imagined. Each generation building on insights preserved in the deep structures of consciousness itself. Each individual contributing to an ongoing project of understanding that spans countless lifetimes. And if that's true, then our current crisis isn't just about whether human civilization will survive the next few centuries. It's about whether this particular experiment in consciousness will contribute to the larger project or become a temporary setback in the eternal work of intelligence trying to understand itself. The search for ancient civilizations becomes a search for our own deepest nature. The question of whether we're alone becomes a question of whether we're ready to recognize the connections that have always existed. The mystery of missing evidence becomes an invitation to develop new ways of seeing that can perceive intelligence in forms we've never considered. Because somewhere in the space between matter and mind, between individual consciousness and cosmic awareness, between the fleeting moment of human existence and the vast expanse of geological time, there might be truths waiting for us. Truths about what consciousness can become when it learns to think beyond the boundaries of any single species or planet or epoch. The investigation continues, not just in the external world of archaeological sites and geological samples, but in the inner landscape of awareness itself. Because the most important discoveries about ancient civilizations might not be found by digging in the ground, but by exploring the depths of consciousness that connects all intelligence across the immensity of space and time. And in that exploration, we might finally find what we've been searching for all along. Not evidence of who came before us, but understanding of who we really are, and who we might become if we learn to see ourselves as part of something much larger, much older, and much more magnificent than we've ever dared to imagine. The universe is vast beyond comprehension, filled with more galaxies than there are grains of sand on every beach on Earth. In that immensity, the idea that consciousness emerged only once, only recently, only here, begins to seem not just unlikely but almost absurd. We might not be the first intelligence to ask these questions. We might not even be the first to ask them on this particular planet. But we might be the first to ask them at exactly the right moment, when the conditions are finally aligned for consciousness to take its next great leap forward. The search for ancient civilizations points us toward that leap, toward a future where intelligence learns to operate on cosmic scales, where consciousness becomes a force of nature as fundamental as gravity or electromagnetism, where the boundary between mind and universe dissolves into something we can barely imagine but might be about to become. The evidence is all around us, written in languages we're only beginning to learn to read, in the quantum foam that underlies all reality, in the spiral arms of galaxies that mirror the structure of seashells and hurricanes, in the mathematical relationships that govern everything from the orbit of planets to the firing patterns of neurons in the human brain. We're not separate from this cosmic intelligence. We are this cosmic intelligence awakening to its own nature through countless forms of awareness across countless worlds and countless epochs. The ancient civilizations we're searching for might not be separate from us at all. They might be us, experienced from a perspective vast enough to see the connections that unite all consciousness across the depths of space and time. And in recognizing those connections, we might finally understand what we've been looking for in all our searching. Not evidence of the past, but the keys to a future where consciousness no longer rises and falls in isolated cycles, but learns to persist and evolve across the eternal expanse of cosmic time. The investigation never ends. It only deepens, drawing us further into the mystery of what it means to be aware in a universe that might itself be the greatest expression of awareness we could ever hope to encounter. And in that encounter, between mind and cosmos, between the ancient and the eternal, we might finally find our way home. This brings us to perhaps the most uncomfortable question of all. Not whether ancient civilizations existed, but why we resist the idea so fiercely. There's something about the possibility that makes us deeply uneasy, and that resistance might reveal more about our current predicament than any artifact ever could. We've built our entire sense of identity around the idea that we're special, that we're the culmination of a long, inevitable journey from primitivism to sophistication, that our technologies, our cities, our understanding of the universe represent the highest achievement of intelligence on this planet. We are, in our own minds, the stars of the cosmic story. But what if we're not? What if we're just the latest chapter in a book that's been written and rewritten countless times before? What if everything we think makes us unique, our art, our science, our capacity for wonder and creation, has been achieved before by minds we'll never meet in forms we'll never recognize? That possibility doesn't just challenge our knowledge of history. It challenges our sense of meaning. If others have walked this path before us, if they've asked the same questions and sought the same answers, if they've loved and dreamed and struggled just as we do, then what makes our existence significant? The answer, paradoxically, might be that significance doesn't come from being first. It comes from being part of something larger than ourselves, from recognizing that consciousness isn't a rare accident that happened once in cosmic history, but a fundamental feature of reality that expresses itself wherever conditions allow. Every thought you've ever had, every moment of beauty you've witnessed, every connection you've felt with another being, adds something to the vast symphony of awareness that has been playing across this planet for longer than we can measure. You're not diminished by the possibility that others have contributed their own movements to that symphony. You're enriched by it. But here's what should really keep you awake at night. If previous civilizations did exist, if they did achieve remarkable things, if they did leave traces we're only beginning to recognize, then their story isn't finished. It's continuing through us. We're not just studying ancient history. We're living it. We're writing the next chapter in an epic that began long before we were born and will continue long after we're gone. Every choice we make about how to treat our environment, how to organize our societies, how to develop our technologies, becomes part of that ongoing story. We're not just responsible for our own future. We're responsible for continuing a conversation about consciousness and possibility that might have been going on for hundreds of thousands of years. The pressure is enormous. But so is the potential, because if we're part of a larger pattern, if intelligence on Earth has been experimenting with different approaches to sustainable civilization for far longer than we've realized, then we have access to resources we've never fully appreciated. Not just the accumulated knowledge of human history, but the deeper wisdom embedded in the very structure of life itself. The organizational principles that allow ecosystems to maintain stability across millions of years. The information processing systems that enable a single cell to coordinate thousands of chemical reactions simultaneously. The communication networks that connect every living thing on the planet in ways we're only beginning to understand. We think of these as natural phenomena, separate from human technology and intelligence. But what if they're not separate at all? What if they're the legacy of minds that learn to work with natural systems instead of against them? What if every forest, every river, every breath of wind carries information about sustainable ways of living that were discovered through trial and error by civilizations we can't remember? The Aboriginal peoples of Australia have a concept called the dream time, a realm where past, present, and future exist simultaneously, where the actions of ancestral beings continue to shape the landscape and guide the behavior of their descendants, where knowledge isn't something you learn, but something you remember. Maybe the dream time isn't mythology. Maybe it's an accurate description of how consciousness actually works across deep time. Maybe every insight we have about sustainable living, every breakthrough in renewable energy, every innovation in ecological design is a form of remembering, a way of accessing knowledge that was embedded in the structure of reality by minds that came before us. This changes everything about how we approach our current challenges. We're not starting from zero, trying to solve problems no one has ever faced. We're continuing work that began long ago, building on foundations we can't see but can learn to feel. Every solution we develop is both innovation and recovery, both discovery and remembrance. And maybe that's why the search for ancient civilizations matters so much. Not because finding definitive proof would change our understanding of the past, but because the search itself changes our understanding of the present. It opens us to possibilities we've closed our minds to. It makes us more humble about our own achievements and more hopeful about our potential. Because if others have walked this path before us, then the path exists. The destination is reachable. The problems we face, overwhelming as they seem, are not insurmountable. They're just the next set of challenges in a long curriculum designed to teach consciousness how to thrive across geological timescales. We're students in the universe's most advanced course on sustainable intelligence. And while we can't see our professors or access their textbooks directly, their lessons are everywhere around us. Written in the resilience of ecosystems that have survived multiple mass extinctions, encoded in the genetic programs that allow life to adapt to changing conditions, embedded in the physical laws that create order from chaos and complexity from simplicity. Our task isn't to reinvent civilization from scratch. It's to remember what civilization really means. Not the accumulation of power over nature, but the development of wisdom about how to live as part of nature. Not the creation of monuments that outlast our bodies, but the cultivation of understanding that outlasts our species. And in that remembering, we might finally understand what the evidence has been trying to tell us all along, that we're not alone. We never have been. We're part of an ancient community of consciousness that spans not just space, but time itself. A community that includes every mind that has ever wondered at the beauty of a sunset, every intelligence that has ever asked why the universe exists, every consciousness that has ever dared to imagine a better future. The search for ancient civilizations becomes the search for that community, and finding it doesn't require digging in the ground or analyzing chemical traces. It requires recognizing the connections that already exist between your consciousness and the vast network of awareness that has been exploring the possibilities of existence for far longer than we've dared to dream. In the end, that might be the most important discovery of all. Not that ancient civilizations existed, but that consciousness itself is ancient, older than species, older than planets, older than the stars themselves. A fundamental aspect of reality that has been experimenting with different forms of expression since the universe began. We're not the first to participate in that experiment, but we might be the first to understand it, and in understanding it, we might finally be ready to take our next step in the ongoing adventure of intelligence learning to know itself across the infinite expanse of space and time. The investigation continues, not in dusty archives or remote excavation sites, but in the living laboratory of consciousness itself, where every thought, every insight, every moment of wonder adds another data point to the longest-running experiment in cosmic history. And you, right now, listening to these words and contemplating these possibilities, are both researcher and subject in that experiment. Your consciousness is the instrument through which the universe studies itself. Your awareness is the lens through which eternity examines its own infinite nature. The ancient civilizations we've been searching for aren't lost in the past. They're alive in the present, continuing their work through every mind that dares to ask the deep questions and imagine the impossible answers. Welcome to the investigation. Welcome to the mystery. Welcome to the ongoing discovery of what it means to be conscious in a universe that might be far more aware, far more intentional, and far more magnificent than we ever dared to believe. The search never ends. It only deepens. And in that deepening, we might finally find what we've been looking for all along. Not evidence of who came before us, but understanding of who we truly are, and who we're becoming in this eternal moment where past and future converge in the infinite now of awakening consciousness. That's all for tonight's journey into the impossible. But remember, the real investigation is just beginning. Every sunset you watch, every star you wish upon, every moment you feel connected to something larger than yourself, you're gathering evidence for the greatest mystery of all, the mystery of consciousness itself and its ancient ongoing experiment with existence. Until next time, keep questioning, keep wondering, and keep your mind open to possibilities that might be far stranger and far more beautiful than anything we've yet imagined. This is Before Law, where the impossible becomes inevitable and the search for truth never ends. So here we stand, at the edge of everything we thought we knew about our own story. We've traced the shadows of possibility through geological layers and genetic codes, through chemical anomalies and cultural memories that stretch back further than our textbooks dare to reach. We've asked the question that makes archaeologists uncomfortable and found that the absence of easy answers might be the most revealing answer of all. The truth is, we may never find that smoking gun, that undeniable artifact that proves an advanced civilization walked this earth 100,000 years ago. The planet is too good at erasing its own history too efficient at recycling the evidence of minds that dare to dream and build and reach for something greater than survival. But maybe that's not the point. Maybe the real discovery isn't buried in ancient sediment or hidden beneath ocean floors. Maybe it's written in the very fact that we can ask these questions at all. That we can look at our own brief moment in cosmic time and wonder if others have stood where we stand, faced what we face, and found ways to persist across the vast expanses that dwarf our individual existence. If they were here, if they rose and fell and rose again through cycles we've forgotten, then we're not pioneers blazing a trail into unknown territory. We're inheritors of an ancient conversation about what intelligence can become when it learns to think beyond the timescales of flesh and stone. Every breakthrough we make, every solution we discover, every moment we choose wisdom over destruction might be continuing work that began long before we were conscious of participating in it. And if we're truly the first, if consciousness on Earth is making its debut through human minds and human hands, then the responsibility is even more staggering. We're not just writing our own future. We're establishing the template for intelligence itself on this ancient, patient planet. Either way, we're part of something magnificent. Something that transforms every choice we make about how to live, how to build, and how to dream into a message sent across geological time to minds we may never meet, but whose existence depends on the wisdom we show today. The mystery remains. The investigation continues. And somewhere in the space between what we know and what we're brave enough to imagine, the future of consciousness itself is being written by every person who dares to ask the impossible questions. Until next time, keep digging deeper than history books dare to go. The truth is out there, waiting in the spaces between certainty and wonder.